This should be the last part of the video for section 4.3. Homework's going to be 79, 81, 83, 87, and 91. After you get done with this section, before you start section 4.4, you should do the extra practice section 4.3 handout before starting 4.4, specifically because section 4.4 has some rules of exponents that you might have forgotten. I'll record a video so you can watch the handout just in case you've forgotten some things from chapter P. A few things are going to come up in this part of the section. Function notation, which I'll kind of talk about as we get into these problems, and square roots with negative numbers. So in this section, at the end of this section, we're going to be making graphs. We're going to be making tables, plotting points, and sketching graphs. And frequently, we're going to be asked to find the square root of a negative number. For instance, we might be asked to do the square root of -9. And if you remember what this radical symbol means, this is asking me, this says, what positive number squared equals -9? That's the question that's being asked by the square root of -9. If I do this on my calculator, do square root of -9, my calculator gives me a math error because there is no positive number that if you square it, you can get -9. My more expensive calculator gives a nicer answer if I do the square root of -9 on my more expensive $100 calculator. It says error, non-real answer. It turns out that square roots of negative numbers are made up numbers. They're imaginary numbers. And when we get to section 4.10, we'll learn that there is an answer to this. This calculator saying this is not a real answer is kind of a nicer answer than math error. But for what it's worth, when we're going to make tables to sketch a graph, when we're asked to do a square root of a negative number, I'm going to make some sort of comment saying this is not possible. If I take the time to put my calculator in another mode that we'll learn later, both my cheap calculator and expensive calculator could do this, but if I put it in a proper mode, it makes the square roots of a negative into imaginary numbers. Square roots of negative numbers are imaginary numbers. You basically just take the square root of a number, like the square root of 9 is 3, and tack on an I to mean it's imaginary. For our purposes right now, if we're asked to do the square root of a negative number, we're just going to say that doesn't exist for graphing purposes. We're going to be making two-dimensional graphs that have x's and y's, and they're not going to show up in our graph. So take these homework problems into your notes. Maybe you can do them as I'm doing the video. So each of the problems in section 4.3 at the end ultimately wants me to sketch a graph. And the first few problems, I'm given a function in function notation as opposed to XY notation and a table. And the instructions say first complete the table. And if you can't read it, it says if we get decimals, I'm going to round to 2 decimals. Quite honestly, that's a little more precise than I could graph. But I'll round to 2 decimals when it's appropriate. So I'm going to complete the table, and I'm going to sketch a graph. The table, every number in the left column is the x-coordinate of a point. And every number that I'm going to wind up putting in the h of x column is going to be the y-coordinate of a point. So I'm going to fill in the table. I'm going to sketch a graph just on a simple xy two-dimensional coordinate system, Cartesian coordinate system. And then I'm going to do something that's new, but it's not particularly hard. Find the domain of the function from the graph and find the range of the function from the graph. I'm going to use my calculator to get the y's. And for problem 80, I'm going to change this function a little bit to make the domain and range part of this more interesting. So I'm going to change problem 80. I'm going to make the function h of x equals the square root of x minus 2 plus 3. And I'm going to use the values in the x column to get y's, and I'm going to use my calculator. So the first number I'm going to take is the number 6, and I'm going to plug it in for the 6, the x in the parentheses to the left of the equal sign, and I'm going to put it in for the x to the right of the equal sign. On the left-hand side, I read this as h of 6, and on the right-hand side, I do the radical first. Under the radical, I get 6 minus 2, which is 4. I do radicals before additions. The square root of 4 is 2. And then I'm going to add the 3. So in my table next to the 6, I'm going to write 5. And what this represents, it represents the point x equals 6, y equal to 5. I'm going to sketch a graph up here because I don't have enough room to do a full-fledged graph down here. So I'm going to plot this point on my x-axis, which is my horizontal axis, and I'm going to create a y-axis, and the function name is interchangeable with y's. Function names and y's are equal to each other. They have the same meaning, but the function is more descriptive of a way to write this. When I read this h of 6 equals to 5, I can see that when I plug in 6, I get 5. If had I just written y equals the square root of x minus 2 plus 3, and I plugged in 6, when I look at this, I can't tell the x that I used to get y equal to 5. But when you plug numbers in for x's, you get y's out. So this first h of 6 equals to 5 is just the 0.65. So I'm going to plot that point the best I can. So go right 6 and up 5. I'm going to make a dot. Usually I don't write the coordinate next to the points because it makes the graph ugly, but for this one I will. Now I'm going to go down and do h of 5, and I'm going to start using my calculator to get all the points. So for h of 5, I'm just going to change that x to 5. I'm going to do the square root of 5 minus 2 plus 3. My calculator is going to help me speed up the process. So the square root of 5 minus by the equal sign 2, out of the square root by using the right arrow, and then plus 3. Make sure the plus 3, the square root doesn't extend under the plus 3. And that's not graphable for me. I'm going to hit the SD button to make it into a decimal, and I'm going to round to 2 decimal places. So my second y is going to be 4.73. And I really can't plot 4.73 very accurately, but I'm going to do my best. So that represents the point x equal to 5. The number that I plug in the parentheses is an x. The number I get out on my calculator is a y. So I go, that's about 4.73, and then over to 5. So up 5 and down to 4. Right 5 and up to 4.73. It's a little bit lower than 5. I'm not going to write the coordinates of the point next to that because it gets so ugly. Next part of my table, I'm going to plug in 4, which is going to be the square root of 4 minus 2 plus 3. Just going to do this on my calculator just to save time. It's more accurate. SD it to make the decimal, and I'm just going to say that's 4.41. It's rounded. I probably should write a squiggly here as opposed to an equal, but this is fine. So that's going to represent the point x equal to 4, y equal to 4.41. So I go right 4, up a little bit less than 4.5, so it's going to be lower. And I should have brought out my graph paper, but I didn't. It's okay. Then I'm going to do h of 3. which is the square root of 4 minus 3 plus 3. Oops, 4 minus 2 plus 3, just changing. It's the square root of 3, changing the x here. It's the square root of 3 minus 2 plus 3. That I could do without my calculator because it's not a decimal. I get 4 for that. So that's going to represent the point 3, 4. So I go right 3 and up 4. So right 3 and up 4. It's a little bit lower. The points are consistently getting lower. I'm going to do h of 2. And h of 2 is going to be the square root of 2 minus 2 plus 3. And that I could do without my calculator as well. But I've got my calculator. It's more accurate generally than I am, and it's faster. That gives me 3. So exactly 3, and that's going to represent the point 2, 3. This is going to be an important point. You're not maybe supposed to know that just yet, but I'm actually going to write this point down because it's going to matter when I go to find the domain in the range. The next 2 points I'm going to get errors for. I can't fit it over here, so I'm going to jam them over here. To do h of 1, I'm going to do the square root of 1 minus 2 plus 3. If I was doing that by hand, I do the 1 minus 2 under the radical, and this is going to be an error or some sort of imaginary number. Square roots of negative numbers are make-believe numbers. And on my calculator, if I did square root of 1 minus 2 plus 3, it's going to give me that math error. And this is going to be a point that's not going to be plotted. There's going to be no point on the graph that has an x coordinate of 1. Similarly, if I did h of 0, it's the square root of 0 minus 2 plus 3. And if under the square root I get a negative number, that's an imaginary number. It doesn't show up on a graph that doesn't have that only has real numbers. So if I did square root of 0 minus 2 plus 3, I get another error. So this is also not going to show up on my graph. So the last 2 values in my x column aren't going to show up. And my graph is going to start at this point 2, 3, and it's going to go through the points that I've calculated. But my table doesn't have every x possible. So it's going to extend past the points that I've drawn to the right, but it's not going to extend past to the left of the point that I have 2, 3, because anything after that point to the left of that is going to be an error. So my graph is going to go more like that. So I completed my table, I sketched the graph, and now I'm going to find the domain in the range of the graph, which is actually kind of easy to do. If I want to find the domain of a graph that's only one connected piece. This graph is just one connected piece. To do the domain, I'm going to find the x coordinate of the left edge of the graph, or the point that's furthest left, and then comma, the x coordinate of the point at the right edge of the graph. And I get a square bracket if it's actually a point on the graph. I'm going to put brackets between on either side of these numbers. On this edge, you would get a square bracket like that. On that edge, you would get a square bracket like that. If the point that is the left edge is a point on the graph, I'd get a square bracket. If the point on the right edge is a point on the graph, I'd get a square bracket pointed that way. And I'd get round parentheses like this if the edge is not a point on the graph. On the left edge, you'd get that kind of parentheses. On the right edge, you'd get this kind of parentheses. So for this, this 0.23, this is definitely the left edge of my graph. So when I go to write the domain for this, I'm going to write the x-coordinate of the left edge, which is 2, and because that's actually a point on the graph, it's going to give me a square bracket. So my domain is going to be square bracket with the number 2. And then you'll notice that I extended the graph and I put a little arrow because I could have made my table have more values of x that are bigger than 6. And for any value of x bigger than 6, I'd get a y. And the y's would kind of fit along this graph. This graph really doesn't have a right edge because if I tried to say this is the right edge of the graph, well, it's not because the graph is going to go up and to the right forever. Similarly, that's not the right edge of the graph. There really isn't a right edge of the graph because the graph goes up and to the right forever, which means the graph goes all the way out to the right edge of the x-axis, and the right edge of the x-axis has an x-coordinate of infinity. It's not a point on the graph, but there isn't a right edge of the graph. When the graph goes all the way to the far right edge of the x-axis, we say the x-coordinate of the right edge is infinity, and that's not actually a point on the graph, so it gets around parentheses. So for this graph, I would say the domain, square bracket x equal to 2, the left edge of the graph, its x-coordinate is 2. I get a square bracket because that's actually a point on the graph. There is no right edge, so when there is no right edge and the graph goes all the way to the far right edge of the x-axis, we say the right edge has an x-coordinate of infinity, and infinities are never points on the graph, they always get round brackets. That's half of what we needed to do at the end here, so now I've found the domain. And the last half of what we get to do is we get to find the range. And range is related to y's. To do the range of a graph, it starts off, if a graph is only one piece, it's not like two pieces. To do the range of a graph that's only in one piece, we start off and we get the y-coordinate of the lowest point. I usually say it's the bottom of the graph. I don't know if bottom is a better word than lowest. Comma, the y-coordinate of the point that's at the top of the graph, or of the highest point. That's going to be the point at the top of the graph. And for this starting, the 0.23, this is definitely the bottom of the graph or the lowest part of the graph. There's no portion of the graph that's beneath the 0.23. So when I go to do my range is going to start at the y-coordinate of the bottom of the graph, which is 3. Just like for domains, if the point that I'm writing, if the value that I'm putting is from a point that's actually on the graph, you get a square bracket. So the range is going to start at y equal to 3. If I try to find the top of the graph, I'm going to get frustrated because this graph doesn't really have a top. I can't say this is the top of the graph there, even though it's maybe the end of what I drew. The graph goes up and to the right forever. So there's no way to really say this is the top of the graph because I could extend the graph and the graph is going to keep getting higher and higher and higher. So the graph really doesn't have a top per se. It goes up to the up forever, and when a graph doesn't have a top and when it keeps going up forever, the end of the range we give for the top of the y-axis, and the top of the y-axis has a y of infinity. Infinities are net points on the graph, so they always get round brackets. So that would be the answer for problem 80 in terms of the domain and the range. And for our square root graphs, for every square root graph we're going to do, it's not for all square root graphs in the world, but for our square root graphs, every domain is going to be of the form square bracket, some value of x, comma, infinity. And every range for our square root graphs is going to be square bracket some value of y comma infinity. This isn't for every square root graph in the world, but it's going to be every square root graph that we do. So the first number is going to be some value of x. It's going to be the x coordinate of the starting point when I'm doing the domain. And for the range, it's going to be some value of y. It's going to be the y value of the starting point of the graph, comma infinity. This isn't universally the case, but for our beginning square root graphs, it's going to be constantly the case. All right, I'm going to pause the video, and I'm going to figure out how to seam these videos together right now. There might be a hiccup.